Okay guys, so we are moving to the next section of my presentation. I hope that the following section will not be so formal as a previous one. And here I would like maybe to motivate you and to engage you. So I am going to talk what are the key items which we are going to discuss in frame of the course, and here I also would like to demonstrate you several real projects, and I hope that this one would be interesting for you. Okay guys, so let's try to go inside and let's try to check or to see what is our course about. So you will be a bit surprised, but actually our course is regarding the decision making. So meaning that decision making is something what any company, any manager is dealing with. And if you would browse the internet or if you would ask ChatGPT, so how a decision-making process looks like, so most probably you will get plus minus the same picture, which indicates what are the stages of the decision making. And here, guys, I would like to pay your attention to the step number 4 and to the step number 5, which says weight the evidence and choose among alternative. So, meaning that in a decision-making process, most probably we have some variants, we have some options, we have some alternatives, and we need to choose one from the set. And here we are coming to the problem how actually to choose. So of course we could apply our intuition, okay, saying okay, my experience is saying, but the problem is that a following approach, it seems that such approach is not really very effective. That's why, guys, in frame of our course, we are going to talk about data and simulation-based decision making. So, meaning that to weight the evidences and actually to get any kind of data which would help us to choose among alternatives is actually the focus of our course. So as you're able to see here, it's just really a very small and simple picture. So we have a stakeholders, I don't know, investors, top management or middle level management, and they need to make the decisions. So using a simulation, using the simulation, we are able to help them, meaning that we could state, guys, here is how the situation looks right now. Here is the new situation. So we have considered it, at example, a following possible solutions. A next one is an our solution, and so on. And we could help them by stating, guys, following solution looks good, but unfortunately not very perfect. So it's really very discussable. Do we need to utilize the following solution? While at example, the following one looks really good. Okay, so our role here is to help stakeholders to make the right decision, and we are helping them or assisting them using a simulation modeling. If you still believe that a simulation modeling is something theoretical one, I would really recommend you to visit a following web page, which is a cloud platform organized by a company AnyLogic, which has a simulation software called AnyLogic, and this one is actually repository of different simulation models which you could run, you could read the description, you could explore what kind of problems were solved using simulation modeling. So the people who prefer to use a mobile phone, here is a QR code, so just scan it and you will get to the correct place. will zoom a bit, okay, and I just wanted to pay your attention that why we are talking about simulation modeling specifically in frame of this program. And here I would like to pay your attention that following platform has some sort of classification of the models, and please pay attention to the top, let's say, categories. Okay, healthcare, we are skipping the healthcare, but I believe it is clear for you that after COVID, simulation modeling become really very popular in frame of healthcare. But next, guys, please pay attention. Manufacturing, transportation and logistics, supply chains, okay, we're skipping artificial intelligence, market and competition, airport, station, malls, road traffic, and so on and so on. So meaning, guys, and probably you are able to recognize that I would say a top 10 of the categories actually includes exactly the categories related with the transportation and logistics. So meaning that this one is a clear indication for you that a simulation modeling, it's not something theoretical. It's something which is really very linked to practice. Okay, so now I would like to demonstrate you several simulation models which were developed here at Transport and Telecommunication Institute, and probably tell a bit about the nature or essence of the problems which we have tried to solve together with our partners and customers. And the first model which I would like to demonstrate is actually the model of a crossroad near Riga International Airport. So the thing which you see right now, it only seems that this one is just a video, a cartoon. So this one is actually the recording from the simulation model. And here I would like to pay your attention to a very important aspect of the simulation modeling, that using simulation modeling we are able to produce animation, 2D or 3D animation of the model. So meaning that we are able to follow what is happening inside the system. And this one is really very useful when you need to demonstrate the results of the simulation modeling to stakeholders or to the public. So you are not overloading the people with huge tables or very complex diagrams or whatever. So you are demonstrating a video or animation, and you are saying, guys, try to see what is happening in the system according to scenario 1, according to the scenario 2. So a few words about the project. As I have stated, a customer here was Riga International Airport, and near the airport there is a quite complex crossroad, which actually is considered, or was considered, sorry, better to use a word, was considered as a bottleneck. So if it's a bottleneck, the first solution, as always, is just to invest €1 million to make a full reconstruction, to create flyovers or whatever. But the problem is that you need to find €1 million, okay, and you need to invest this one. Therefore, the task for us was actually to think about and maybe to find the possible solution of how we are able to optimize a circulation of a traffic flow in this node. And finally, as a result of our study, we have found out a configuration which would allow to optimize the movement or circulation of a traffic flow without huge investment, just adjusting traffic lights, just adding several new lines. Okay, the next model which I want to demonstrate you is the model which we have created in frame of a project with Riga city municipality. And here the problem or the essence why actually we have implemented the following project. So as you're able to recognize, this one is a transport network. So nodes here represents the specific crossroads and lines represents roads. And this one is a fragment of transport network of Riga city, which is located in the city center. And the municipality had an idea that maybe one of the street which is having the title Terbata Street can be closed for traffic and can be open only for pedestrians. So we have completed data collection and simulation of the following part of the network. But as you're able to recognize here, I am not demonstrating you a video, but here we are using, I would call them infographic to demonstrate the overall results. So here is one of the scenario which shows what will happen with a transport network if we will close a first part of a mentioned street. And the key results here are demonstrating using something which is called LOS, level of service. And according to the legend here, you are able to catch up that probably A, B, C means that everything is fine with a crossroad. A level D actually means that here could be potential issues, and for levels E and F it means that there is a bottleneck, a congestion, the issues. And using such kind of diagram, yeah, I could call it a diagram, we could easily see, and stakeholders could easily see that, okay, after closing a following part of the street, we will get a problem we will get a problem here, we will get a potential problem here, and we will get a potential issues here. So this one is one more approach of how we are able to visualize and communicate the data to the stakeholders. Of course, you are able to recognize that we could go deeper inside to the node and we could see what is actually happening in this specific node. So one more example, and in this case I am going to talk a project which we have implemented with Bauska city. It's a small city located around 50 kilometers from Riga. So what was the essence of a problem? As I have stated, the city by itself is not very huge, and across the city goes a main road which I am demonstrating right now. And the problem is that the following road is overloaded, and more specifically a following road is overloaded with cargo vehicles. So of course you will say, what's the story? What the cargo vehicles are doing in the city? The answer is really very simple, that a following city is located not far from our neighbor Lithuania. And actually a following road is the only one of how traffic could get to Lithuania. So what's the story? Where is the problem? And what specific is in a following project? The issue is not in traffic flow as it, but the issue is with ecological issues. So meaning that cargo vehicles are producing a lot of pollutions, and our goal or our task in frame of this project was to test two different scenarios. The first one is the current situation, okay, and for current situation we have evaluated ecological measures like CO2 or PM10. Okay, and the second scenario is actually when we are removing cargo vehicles. Of course, we are not able just to remove vehicles. The idea was that it will be constructed a bypass road around the city. And as you're able to recognize for following scenarios, volumes of pollutions for CO2, PM2 are let's say less, so we see a decrease. But guys, probably you would say, Mikhail, clear that if you would remove cargo vehicles, the situation will become better. Yes, it's true, but the good thing about the simulation, that a simulation is producing us quantitative numerical data. Okay, meaning that we are not just stating that the situation will become better, but using the numbers, we are able to demonstrate what would be the impact. The next project, which I would like to demonstrate and to describe a bit, is a project with our industrial partner, which came with the following issue. So the company decided to implement a new service for the citizens of Riga, and the service was the following one: that in case of emergency, so the company is promising to arrive in 2 hours, okay, and somehow solve the emergency problem. So, and a following condition, I mean to arrive in 2 hours, a company wanted to include into the contract with a customer, with their clients. And as you're able to understand, that this one is really very risky. So meaning that if the company is not able to arrive in 2 hours, so they are promising that they will deliver the service for free. That's why for the company it was really very important to understand how many resources they need, okay, to implement a following promise with quite high probability, meaning that they wanted to reach a situation when in 95% of the cases a company is arriving in time, so in frame of 2 hours. Of course, when I am saying the company will arrive, it's quite clear that there are some specific peoples, okay, staff which arrives and removes the issue. So that's why we have developed the following model, which you see right now. This one is Riga city. The dots which you see here are actually randomly inserted clients, okay, and as you see, the company wanted to operate in a radius of 50 kilometers around the Riga. So next one, you could see different kind of resources like operators, workers, and the experts. And the most important information for our client was the following simple pie diagram, which demonstrates how many or what is the percentage of arrivals completed in time, so in frame of 2 hours, and the red one means how many arrivals were with a delay. And the goal of our simulation was to indicate how many resources were necessary to again reach the situation that 95% of arrivals would be completed in time frame. The last project for now, which I wanted to demonstrate you, is a project which TSI implemented together Riga International Bus Terminal. Again, you are able to see the model, and probably you are able to see that this one is animation, maybe not so beautiful as I have demonstrated before, but still animation. So in this case, I just wanted first of all to highlight the problem which we have tried to solve, and the key problem was dedicated to a safety aspects of the passengers. So meaning that it was planned some reconstruction of the bus terminal, and some of the platforms according to reconstruction plan will be closed, meaning that in this case somehow departure and arrival of the buses shall be organized in a different way, and this one immediately would impact the movement of the passengers. Okay, so first of all, I would like to pay your attention that a model by itself is organized in a such way that here are some tabs, meaning that by pressing this one you could see a 2D model of a following system, a 3D model, and you could get some statistical data. Also, I would like to emphasize that a following coloring map is called a heat map, and actually this one demonstrates what is the density of the passengers in the specific point of the platform or area of a bus terminal. So moving that this one is a key result which was delivered to our customer, which allows to catch up a potential places, a potential problems in which additional attention shall be put.